Really? Bubbles? Science, mathematics, and engineering is supposed to be boring, not entertaining. So, in today's episode, you'll learn how to calculate the height of a falling object. Now you may ask, where am I use this in real life? Well, think about baseball, or football, or even soccer. So to demonstrate this technique, we'll need to set up the pop fly machine. Well, let's get crazy and set it up. People usually find the pop fly machine as a curiosity. Let's check out the operation of the pop fly machine in slow motion. In our first experiment, launching a baseball into the air, we will use 3 springs on the pop fly machine. By measuring the time it takes for the baseball to fall to the ground, we can calculate the height of the baseball. We measure the time using a stopwatch by starting the stopwatch at the apex of the ball's flight and stopping it when the baseball hits the ground. We calculate the height of the baseball using this formula, that is, the height of the baseball is equal to the Earth's gravitational acceleration constant g divided by 2, then times the time it takes the ball to fall to the ground, or the fall time. We multiply this again by the fall time. We can also say the height is equal to the Earth's gravitational acceleration constant g divided by 2 times the fall time squared. The Earth's gravitational acceleration constant g is equal to 32 feet per second squared, or 9.8 meters per second squared. The measured fall time using 3 springs was 1.4 seconds. We take the time and multiply it by itself. Then multiply the result by half of the Earth's gravitational acceleration constant, that is 16 feet per second squared, to get a height of 31.4 feet. If we want the height in meters, simply multiply the time squared by 4.9 meters per second squared to get a height of 9.6 meters. Let us increase the height of the baseball using 4 springs on the pop fly machine. The measured fall time using 4 springs was 1.53 seconds. We take the time and multiply it by itself. Then multiply the result by half of the Earth's gravitational acceleration constant, that is 16 feet per second squared, to get a height of 37.5 feet. If we want the height in meters, simply multiply the time squared by 4.9 meters per second squared to get a height of 11.5 meters. Now, we will use 6 springs on the pop fly machine to increase the height of the baseball. The measured fall time using 6 springs was 1.67 seconds. We take the time and multiply it by itself. Then multiply the result by half of the Earth's gravitational acceleration constant, that is 16 feet per second squared, to get a height of 44.6 feet. If we want the height in meters, simply multiply the time squared by 4.9 meters per second squared to get a height of 13.7 meters. We can also calculate the height of a baseball from a photograph, such as in the case with the baseball hitting the guy wire. You can download this image from our website at earthenergyandeducation.org under the Pop Fly Project menu. The photo shows a side view of the pop fly machine and a baseball high above. The trick to calculating the height of the pop fly is knowing the length of an object in the photo. In this case, the support of the pop fly machine is exactly 10 feet in height. Keep in mind, the reference object must be in the same vertical plane of the baseball. You cannot use the reference to measure the height of the building in the distance, since the support of the pop fly machine and the building are in two different vertical planes. We need to measure the height of the support on the pop fly machine using a ruler with millimeter units. In addition, we need to measure the height of the baseball using the same ruler. Be very careful when measuring on a computer with a liquid crystal display or LCD display, as a sharp object could damage the surface. We can calculate the height of the baseball in feet using a scaling method. In this case, the scalar is a ratio of the height of the baseball divided by the height of the support on the pop fly machine, with both heights measured in millimeters. We multiply our reference of 10 feet with the scalar to get the height of the baseball. We hope you learned how to calculate the height of a falling object using indirect measurements and witnessed our wonderful little bubbles. To learn more about science, math, and engineering, please visit our website at earthenergyandeducation.org. So from us to you, keep discovering your earth and the heavens, as well as energy and education.